today?
Yeah.
Yeah. Okay,
Can I have like a cup of water?
Yes. Javi, un poquito de agua para mojarme. Bueno, como sabéis, esta charla va a ser en inglés. Voy a hacer un poquito de introducción en castellano y voy a presentar a Mohamed en inglés. Bueno, gracias por venir y sobre todo con tan pocos días que tuvimos Javi la semana pasada. Y, well, first I want to thank Mohamed for coming and bueno, y también hablaré que también dar las gracias a JUG, que son una empresa nueva que se acaba de instalar en Valencia, en Alcira concretamente, y que nos va a patrocinar las pizzas de después, así que hoy tendremos pizzas para todos. Y darles las gracias también, y por supuesto a Jeff, ya no, a Jeff, por cedernos el espacio. Así que nada, if you want, you can start.
Yeah, okay. All right now. Let me just check. Okay. Hello everyone. My Spanish is so bad, so I switched directly to English. Thanks for coming. I know it's hard to be here in the middle of the week, so thanks for coming. And my talk today will be about containers in Java and the things that we should know before like putting a Java application inside a container and deploy it into production. If you have any questions, please feel free. The session is prefer the session to be more interactive. If you have any question, just stop me, and it could be even in Spanish. I have my personal translator who can help me to understand things. So this is just a quick presentation about me. I work at XHub, which is like a DevOps company in Spain, in Valencia, and specifically in Alcira, Morocco, and Canada as well. And in this talk, I will highlight the story of a Java developer, which is called Farouk. And Farouk has been a Java developer for a couple of years now, and he truly believes in the power and limits of code. So he keeps hearing about this new technology called Docker and containers, and he wants to start to playing with it, see what benefit it offers, and what headaches it comes with as well. So my talk today starts with somehow the philosophical question: is it a good idea to put a Java application inside a container? We will discuss afterward how to create effective Java images that are both faster, smaller, and secure. We will see some tools and libraries that helps working with containers in Java a lot more easier. And we will discuss the things that we should know and the things that we should avoid before deploying our containers into production. And finally, we will discuss and highlight some features that has been added to Java to make it more containers aware. So nowadays, containers are everywhere, and they are used for a wide range of applications. Like we use them from fast serverless application to huge enterprise monolith applications. And that's because they offer a great number of benefits. They offer they make deployment a lot more easier. They make scaling up and scaling down a lot more enjoyable. They advocate this new style of architecture, which is like the coupled architecture and microservices-oriented architecture. They advocate also immutability and declarative configuration, which is mainly based in YAML files. And they allow efficient resources utilization, especially in the cloud, because of this lightweight isolation that the containers offer that allows more dense packing in our servers. And one of the great benefits of using container, it's the rich and vibrant ecosystem that offers a lot of tools and a lot of solutions that helps deploying containers and monitoring them a lot more easier. And the backbone technology behind lightweight isolation that allows the dense packing are basically namespaces and G groups. And namespaces are used for providing different isolated view on the system. So each process will have its own view on different namespaces, like process ID, network ID, user ID, and so on. C groups, on the other hand, are used for providing limiting and metering for the resources that can be used by a process. So in C groups, each subsystem forms a tree structure or a hierarchy of nodes, and each process belongs to one node and one node only. So for example, given a process, each one belongs for one node for CPU, one node for memory, one node for network I/O, and one node for storage I/O, and so on and so forth. So if you think about it, initially when the system boot, if you are using like Linux containers and Linux in your production servers, when the system boot, there is one node, one big node. And if you are not using containers yet, you are just using, like in your production system, one big container with no limitation on and no constraint. So if you are not using container yet, it's your server, your production server is basically one big container with no limitation and no constraint. So this is good. And our friend Ferro started wondering, is it actually a good idea to put a Java application inside a container? Especially that the JVM offers a great number of benefits. The JVM is hardware and OS agnostic, and it's runtime adaptive, which means that the JVM will try to tune itself and adapt itself to ensure the best execution environment in our production system. However, like Ferro decided to give it a try, and after reading a couple of tutorials, he came up with this Docker file. So it's not the best Docker file that you could find on the internet, but however, it built it, it ran it, and it's running perfectly. And then Ferro asked himself, what I actually need from my container? What characteristics my production container should have? And the answer is basically three things. So I need a good base image that contains my runtime dependencies. I need my images, my production image to be as small as possible. And finally, I need my container to run as fast as possible. So first things first, and when we talk about the base image, and in the context of Java, we talk about the JDK itself and the G area itself. And there were like a huge discussion lately about the future of Java, especially after the new release cadence, which is 6 months now, and the new licensing from Oracle. But Java is still free, and there are many providers that are offering it for free. Even Amazon now with Amazon Corrito, they're offering their own build based on OpenJDK. And as Dr. Venkat Subramanian loves to say, there is no such thing as end of life if you have enough money. So if you need support, there are also, for your production system, there is also a lot of companies, many companies, that offer that as well. So that was for the base image. And for our production container images, we need them to be as small as possible. And for that, there are a couple of techniques that we can follow from both the Java side and the Docker side. So from the Java side, there is a feature that was introduced back in Java 9, which is Java modularity and Project Jigsaw. And this feature enables us to tailor the JVM to select only the modules that we need during runtime. And we will have a demo afterward that highlights this feature. And it enables us to make also our own custom GUI, putting this JVM in a strict diet. Techniques like code refactoring and code review helps also to reduce logic complexity, reduce the overall line of codes, and helps you detect also if we are using like a whole dependency for just a small utility function. And talking about dependencies, there are many tools, both in the JVM itself, like GDEPs, and others like available in Maven and Gradle, that enables to detect what dependencies we are effectively using during runtime, and what dependencies that are just sitting there and we are not using them and they are like zombies. From the Docker side, it is a good idea to use a smaller base image. And the smaller your base image is, the smaller your final image will be. Understanding the concepts of layer of caching of Docker also helps to reduce the final image size, but generally speaking, it is a good idea actually to combine related comments into the Docker file, and of course like separate the unrelated comments. Also, cleaning up right away, and while working with Docker, it is actually a common practice to download an archive, extract an archive, maybe move the files in another directory in the container, and then forgot to remove this archive. So removing this kind of files, as well as some log directory and some cache directories, helps to reduce the final image size. Using Docker ignore, and Docker ignore is very similar to git ignore that we use with Git, but it's for Docker, and it helps to reduce or ignore some files that we don't need them during the build time, like the Git directory files, some log files, and some temporary directories. And one nice effect of using Docker ignore, it helps to speed up the build process, since during the build, the Docker daemon, the Docker CLI, sorry, need to send some files to the Docker daemon, and using Docker ignore, we can like reduce the size of the context. Also, there is a feature introduced a couple of years now, which is the multi-stage builds, which enables us to define multiple stages in our Docker file and help to keep our production image clean without the unnecessary build files. And finally, using Docker Squash, and Docker Squash is a utility function that aims to squash the images in order to ensure to create another image with smaller layers. And the new created image will work exactly the same as the first one, but it's just remove some unnecessary files. And there is also an experimental command, which is --squash in the Docker build command, which is intended to do exactly the same thing. And you might hear of Alpine in the context of containers, and Alpine is kind of the ideal Linux distribution for a lot of applications out there. And Alpine is a very lightweight Linux distribution. Its size is almost 4 megs, and it's based on muscle libc and BusyBox. So very briefly, BusyBox combines tiny version of common Unix utilities, and muscle libc is the implementation of libc, which is the standard, like as the standard C library, which is basically like do such things like opening files, some networking stuff, and many common OS utilities. But there is one big difference between Alpine and muscle libc and like other Linux distribution that we are familiar with in our production systems, which is like Alpine is based on muscle libc, and other Linux system distribution are using glibc, and those are both two implementation of libc, which means that a C and C++ code that is compiled with muscle libc will not work on glibc and vice versa. So you may be wondering why we are talking about C++ code in the middle of a Java session, and that's because we as Java developer are using a software that has a lot of C++ code, C and C++ code to be honest, to do a lot of its work, which is the JVM itself. So the JVM contains like kind of 60–70% of its code in C and C++. So the JVM has been already ported to glibc, but not yet on muscle libc. So the JVM will have some problem if we run it in top of muscle libc. And the community is aware of that. And in order to port the JVM in Alpine, there is a nice project called Portola, which is you can start playing with it as part of the early access of Java 14. It was like it started back in Java 12, and then push it to Java 13, and then now in Java 14 as it's not production ready. And you will find many images in the internet and in Docker Hub that are based in Alpine, muscle libc. And what these guys are doing, they are just adding the glibc Alpine package on top of Alpine, and they are not using any Portola. They are not using Portola on any Java like JVM port on Alpine. And this slide shows clearly the impact of using a smaller base image on your final image size. And the winner by far is the OpenJDK GERE Alpine image, followed by two other images coming from Google Cloud Registry of Java 8 and Java 11. And those projects are part of a cool project from Google, which is called the Serverless Container Images. And this project aims to create container images that contains only your application and its runtime dependencies, restricting what's inside your application to exactly what your application needs during production and during production runtime. So those images are built using Google Bazel tool. They support multiple languages, including Java, of course. And they provide like very lightweight images. And one nice thing about this project is the base image they are using. It's a very lightweight image, which its size is almost 8 megs, and it's glibc based, which can be considered as a nice alternative to Alpine. And someone would ask, why should I care about like restricting and reducing the size of my container image? And the answer is, the smaller is better. And the long answer is, each time you are like pushing or putting your container, you are incurring costs in terms of data, and network expenses. The smaller a container is, the fewer components it contains, the smaller the surface attack, and it enables also effective tracking, which is like for when you run some security scanning tool for your images, it enables like the false positive signals and the noise of scanners. And the final thing we need from our container is to have a fast startup, and the easiest way to achieve that is to start using Java 11 or later, since Java 11 has by far the fastest startup compared to Java 8 and Java 9, and it's for now the only LTS version based on the new licensing from Oracle and the release cadence from the Java community. Other techniques exist as well, and we will be discussing them in the demo. So I have a small project here which have multiple branches. So the master branch, it's simply a Java application. It's basically a niche application that has that starts a niche server, and it then prints hello world whenever it receives a request. The application starts on the port 8080, and my Docker image for the master branch is simply running with the JDK 13, which is the latest image, without no optimization and with no features. I have other like multiple branches, and each branch represents a feature that enables me either to reduce the size of my image or to improve the startup time. So we'll start with the startup time, as we didn't discuss it till now. And I start by the class data sharing. So I switch very quickly to the CDS branch, which is the class data sharing. So for the class data sharing, I'm using the same code, but now I'm using the class data sharing. And when the JVM wants to run a class or a bytecode, so it grabs the class name from the Java file, from the archive file. It looks for the exact class name. It loads the bytecode. It verifies the bytecode, and then puts it into an internal data structure. This takes some time, and it is most noticeable when the JVM runs hundreds and thousands of classes during startup. But the thing is, if the code inside the jar does not change, the generated data will be exactly the same whenever we want to run our application. So the idea behind class data sharing is dump this data once, put it into an archive, and then share it between multiple JVM instances and then multiple containers. So for Java 13, dynamic class data sharing has been introduced, which means that once the application, we can add simply an option that says that archive the class at exit, and it will automatically generate the class data archive for us. So we can use it in our production image so that whenever the JVM needs a class data archive, it will look in the archive first, and then if it found it, it will load it directly. If not, it will do the same thing. The same usual thing, of course. So before Java 13, there was no dynamic class data loading, the class data sharing, and then for what we did is creating a list of applications that we want to run, and then we create based on the we create the list of application classes using the dump loaded classes list, and then we generate the dump using two comments, which is the xshare dump and then dump loaded classes and from the list, and this generates an archive from us that we can use in the production image. So that was very briefly the class data sharing feature. There is another feature which is ahead of time compilation, And the idea behind the head-of-time compilation is actually inspired from the JIT compilation. So during runtime, the JVM collects some profiling data. And based on this profiling data of our application, it compiles the most executed code into native code. And that enables the JVM to produce highly optimized code and improve the peak performance. However, during startup, the JVM does not benefit from that since the code is not yet JIT compiled. So the idea behind ahead of time compilation is to compile our code ahead of time into native code in order to improve the so-called warm-up time or the startup time. So for that, we use the GEUTC command, and which is this one. And we need to provide the JVM. So what we do is we generate a list of touched method and the classes that the JVM compile during startup. The file will look somehow like this. So this is, so for my example, there is like kind of 7,000 or something methods or classes that JVM loads during startup. And the file that we need to pass to the GEUTC command looks somehow like this, which contains two prefixes, which is compile only or ignore, and the list of methods or classes that we want to compile ahead of time. And for the compilation, we use the GEUTC command, and it has a lot of options. We can compile the file, a list of classes or methods. We can compile a module, and we can compile even a job. So in my example here, I'm using like the compile commands to compile the file. I'm using the module to compile the modules, and I'm compiling my Java application as well. And I need to pass, of course, the list of dependencies that my jar is using. And then this enables the JVM to generate a native code, which is this one. The native and I'm using the multi-stage application to grab the native code from the build stage and put it into my production image. Last but not least, I'm going to show a cool project from Oracle Labs, which is Graal. Anybody hear about Graal before? So Graal is cool. So only one. So Graal is a very cool project from Oracle Labs. And it's pushed the ahead of time compilation a little bit further. And so Graal is basically a universal virtual machine for multiple languages, like JavaScript, Ruby, and Java, and many JVM languages. But what excites Java people about Graal is a sub-project called Substrate VM, and it enables to compile our application ahead of time, of course, into native code. And this enables to execute our Java application without the JVM itself. So it's improved the startup time, and the generated image will be very small since there is no JDK and no JArray. So for that, we use the native image command from the Graal people and to compile our application directly. And of course, there are some optimization that we need to pass, but some tips and tricks to compile it. So Spring Boot, they are working with the Graal guys to generate native images. They have already a small application, a Hello World application, but they are working to make it production ready by mid of next year. Another cool project, which is I forgot the name, which is like it's like Vertex, not Quarkus, another one. Micronaut, yeah. So Micronaut, it uses another approach. So Spring, it's based on reflection. Micronaut doesn't use any reflection, it's reflection free, data caching free. That's why it's Graal friendly, and the support for Graal comes. So each version of Graal works very perfect with Micronaut. So Micronaut is a very cool project, and you might consider it for your next microservice application. So there are some very popular projects that are not working yet with Graal, but it's something to keep in track and to consider in the future because it's kind of the hype now. So that was for optimizing the startup time, but I still have some branches. So I have Alpine, as I've mentioned it. So I have also modularity, which is this one. And for the middle, okay. Don't do this at all. Okay. Come on. The following intricate 3 file would be overwritten. I don't. Okay. Thank you. Please. Okay. So for the modality, which is Project Jigsaw, we are using JLink. And JLink is a command line tool that enables to generate a custom GERE. So what I'm doing here is I'm selecting the modules and adding the modules that I only need to run my application. And I generate my custom GERE, which is this one, which I call it Nitty Runtime. And then I'm using the base image from the distro, which is HMix, and then adding my custom GERE, and finally running my application. I could do this. I could do the same thing with Alpine. So I'm using this. Here is like I'm using JLink, but instead of using an ordinary JDK, I'm using Project Portola, which I downloaded from early access of Java 14, and I'm doing the exact same thing and then running my custom GERE on top of Alpine and using Project Portola for that. So if I run the project, if I go back to master, I have some benchmarking scripts which comprise for each branch the startup time and the size of the image. So if I run the script, I will have some results that looks something like this one. So compare it to the plane, which is my master branch, using AUT and CDC, improving a little bit the startup time. However, it does not help for the size. For Alpine and modularity based on GCR image. So the difference here is basically the difference between the two images, since Alpine is almost 4 megs and the base image from GCR is from the Strolless images are 8 megs. And finally, using Graal, the Graal image is only under 10 megs for the whole application, and the startup time is super fast. So you mentioned Quarkus, and Quarkus use a lot of Graal. So they have like some amazing benchmarking results compared to this one. So that was for the fast startup. I did the demo. So containers are changing the way we develop, architect, and deploy our applications to become the executables of the cloud. However, they do not make things easier for the developers, especially the Java developers, since we are familiar with a lot of tools to generate our Java archive. And the ideal scenario for us is to use the exact same tool to generate this new unit of deployment, which is containers. Because if we look at a typical day in the world of containers, we need first to generate the archive using Maven and Gradle, and then build the image, and then push it into a registry, and then deploy it using Kubernetes or whatever orchestration solution you are using. And this added some overhead. So the ideal scenario could be like using the same good old tools like Maven and Gradle, and to generate this new unit of deployment, and why not like deploy it into, or push it into the registry. There are many tools that we can use for that, and the easiest way to achieve that in Maven is to use the Maven exec plugin and to inject Docker comments into your POM file, into the Maven lifecycle. However, this solution is not so elegant, and other more sophisticated, more robust plugins exist, such as the Spotify plugin from Spotify, and this plugin is the embodiment of simplicity, since it only builds your images and pushes into a registry. Another cool project from Red Hat, which is the Fabric 8, and this project and this plugin has a lot of features, support building images, pushing it, viewing logs, exporting ports, and many other cool stuff. If you are using Gradle, there are many plugins that offers more or less the same feature, And one other project worth mentioning is Google Jib. And Jib is a Java plugin available in both Maven and Gradle, and it enables us to build images without the need of a Docker file and without the need of Docker install it on our machine. So a Docker file, if Jib uses a Docker file, it would somehow look like this, but Jib does not use a Docker file. And so Jib, since it's a Java plugin, it's available in both Maven and Gradle, it understands our application and split the application into multiple layers, putting the files that are more likely to change, which are the code files at the bottom, and the files that are less likely to change, which are like our dependencies and the resource files on the top. And that enables to speed up the build process, since if we made some changes, we don't need to put everything into jar and then generate the new image. We only modify these small, tiny layers, and it helps to ensure reproducibility. So it's a cool project. It integrates easily with Maven, and you can generate your images, and it could be on your CI pipeline, so you remove the need of using Docker on your server. Another core project from Docker Design, which is BuildKit, and there are a couple of problems with the new Docker builder, since it cannot run commands in Dockerfile in parallel, so the only way is to run them sequential. There are some problems with the mounting volumes. It pollutes your directory with some owned files. So BuildKit aims to solve all these problems, and it's basically aims to be the next generation builder for the Docker build command. And BuildKit comes with a lot of features, since I've mentioned it. As I mentioned it, the parallel run of unrelated comments in your Docker file. It keeps tracks of the changes, so it doesn't need to move all the files and load all the files to the context. It loads only the files that are that changed and that help to improve reading your file system. And it comes also with expanding the run command with a specific mount type, which is a cache type. And this one, you can use it with your, one of the big problems while working with Docker is if you run the build into the Docker, whenever you modify your code, you need to rebuild your application and then download the whole dependencies. Because the Docker files, once you modify one layer, all the layers that come afterward need to be re-executed and rebuilt. So with the cache mount from BuildKit, Docker keep a cache, an internal cache, and all the dependencies will be saved with Docker, and then whenever you want to run the application, it will be saved here just like your local Maven repository. So this improves the build time, since you don't need to download the same image, the dependencies each and every time you run the build. And this feature is available as an opt-in feature in BuildKit. If you have Docker 1809 or before, you can enable BuildKit, and you can enjoy some benefit and some productivity in your while building and running your Docker application. Another important practice, not only in containers, but in software engineering in general, is tagging your images. And there are many politics and many policies that we can follow to tag our images, and nothing stops you from combining those techniques like same version and calendar version. But one thing to keep in mind is to avoid using latest, specifically with orchestration tools, since it's not dynamic. So if you do not, it's not added by default. If your tag, if you don't leave the tag empty or specify latest, it would not be created by default. It is not descriptive, since orchestration tool use specific tag to run update and run rollbacks. So if the update will be latest and the rollback will be latest, it will create some crazy stuff with your orchestration, and it is easily overwritten, since it's the default value it makes it very vulnerable to human errors. And this is mentioned in the Kubernetes documentation, which is now the most used orchestration tools for containers. So preferably to avoid it while tagging your images, especially your production images. Another important topic, which is security. And this needs a session on its own, but my goal here is just to give you some bullet points to keep in mind while running containers into production, starting with knowing what's inside your containers. Especially if you are using a third-party container, you need to make sure that those containers does not run anything during runtime. You could run your image against some security scanning tools like Aqua Microscanner or Docker AE offer this one as well. You should verify your application as well and run it against some vulnerability scanning tools. And for Java, there are many. Using Docker content trust, and when enabled, the Docker daemon will use the private key of the pusher to tag the image, and when a later user wants to pull the image, the Docker content trust and the Docker daemon will automatically verify the image for authenticity, integrity, and publishing date, and many other things. So once it enables, the Docker daemon ensures some security best practices. Adhering to the least privilege principle, this one is it's so important. It's a general principle in software engineering, and advocate that we need to run our processes with the minimum set of access rights and resources. In the context of container, that means that we should not run the user inside the container as root. So even if an attacker succeeds to exploit a vulnerability, that does not give him a root access. Also, running the file system as read-only if you don't do write permission. So if an attacker succeeded to exploit a vulnerability, that does not give him, he could not save malicious data and malicious script. And finally, limiting the resources that can be used by a process and by a container helps to avoid some kind of attacks like DOS attacks. Also, as I said previously, using a minimal OS container helps to reduce the service attack. And finally, having monitoring and auditing tool in place helps to detect malicious behaviors and trigger alerts if needed. Another important practice is integration testing and testing in general. And testing helps to make sure that the code we write works according to specification. However, and especially in integration testing, it is hard to achieve this real-world isolated environment. And containers help it to ease this process and to achieve this isolated environment. And one project that should be mentioned is test containers. And test containers is a cool Java library that supports many JVM testing tools. And it provides a number of great features like port randomization, container screen up after the JVM shutdown, and it's really easy to use and to start with. So it's a cool project. And with that, our front row is really to deploy its application into pre-production, since it's super easy, super awesome application was working perfectly in dev and QA environment. So Furrow application is a very simple application. It's basically the Spring Boot Pitch Clinic application. So I'm going to run it without no limitation and no constraints. So let me run it first and using Docker run. And the thing to mention here is, so in my Docker file, I'm using to show the VM settings. During startup, the JVM prints what values it use for the startup. So here the JVM is using almost 2 megs as the maximum heap size. And that's because I'm using Docker for desktop for Mac. And if I run Docker info, I'm telling Docker to use up to 8 megs of memory. Where is the memory? So it's here. So it's almost 8 megs. So the JVM sends the default value for the JVM for the maximum heap size. If no parameter was passed to the JVM, it's the 1/4 of the available memory. which is 2 megs of 8 megs. So the application started, and if I open the application, you could see it's a simple, basic Spring Boot application, which is basically the Pit Clinic application. So now, let me close the application, and one of the great benefits of using containers, as I mentioned in the beginning of the slides, is the dense packing and this lightweight isolation and the resources constraints that we can use and the resource optimization containers offers. So for that, I'm going to run the application and limit the memory to 250 megs and give it a name. So let's give it a name to be SPMC 2050. Oh, it is drawn. Oh, okay. Dash P. This one should, okay. Demo got. But the weird thing is, the JVM is completely unaware of the constraint that I put to it. So I told my container that it can use only 250 megs, and the JVM still thinks that it can use up to 8 gigs and put its maximum heap size to 2 gigs. And that will lead the JVM to death, because normally, ideally, if things works according, it will fail to start, and it's not exec, it's inspect. If we run docker inspect command, we could see that it received an out of memory kill signal, since the application used more memory that it allows to use, and that which mentions the JVM is completely unaware of Docker and containers constraints. So basically what happens is the JVM still thinks that it could use up to 2 gigs of memory, and the container and the Docker daemon have a limitation to use that if the container uses more than 250 megs, it will kill the container, and that's exactly what happens. So our applications, our application wanted to use more than 250, and then it received a kill signal from the Docker daemon. So we are Java developers, and when we have some issues with the memory, we add more memory. So let's add some memory, and let's make it 500 megs. Weirdly, the application said it could use up to 2 gigs, completely unaware of containers constraint, but this time, so let's play a game. Let's do a quick poll. How many of you think the application it will start? Okay, it started. That was quick. So the application started weirdly in my desktop, and that would not happen in your application or in your production server when you have more memory. Normally, when we talk about production servers, you have like 64 or more. So this will not be the case for your production server. But my application started weirdly, and if I exec, so I'm going to use the GCMD command, which is the G command, which is basically send diagnostic requests to the JVM, and it collects some data about the state of the JVM and some monitoring information. And I'm asking, so for the GCMD, we need to specify the process, and since I'm running into a container, I have only one process, which is my application, and it's a JVM, of course. And I can send requests about many information, like the flight recorder, the process, but here I'm tracking only the native memory, and I'm specifying the scale, or the unit of measure, to megabytes. And the answer of my request, it says that the application uses more than 500, and my application uses up to 800 megs, which is weirdly, even if I specified that my container could use up to 500 megs. And the quick question is, the application is actually using swap. Normally, in your production system, you will disable swap in the host level, but if we disable swap in the application, and that's we use normally memory swap if my memory is good, and specify the same value as the memory. Okay, so it should be memory swap. Okay, so the name. And this says no swap. Cool. So how many of you think that the application will start now? Doesn't start? Oops, it's weird. Normally it should not start. I probably missed the comment. So Docker help and okay. The memory swap. If my memory is good, it should be the memory swap. 500 megs. I don't know what exactly happened, but normally the application should not start because of the memory. Okay, let me try to find my history and find the swap. This should be this one, probably. Okay. Okay, see. Hopefully it will fail this time. But if it doesn't, it's weird because normally, okay, so what happened, I'm using Kubernetes, I think. Okay, so now it failed. So now the demo is working. I think I missed some misconfiguration or something for the Docker comments. But when we disable swap, so the application is limited to 500 megs of memory, and then it uses more than 500 megs, and then it fails to start. Okay. So first application failed badly in its pre-production system. And first started to want to collect some answer and understand why this happened. And the first part of the answer is from history. So the containerization movement started back in 2000s with Solaris jails, and in 2006 and 2008, the first with C groups and namespace appeared, the backbone technology behind containers. And when Docker appeared in 2013, the containerization movement exploded in popularity. However, Java was there since 1997, the very first version. And when Docker first appeared, Java 7 was already out, and the work on Java 8 already started, which explains somehow why the JVM is not container aware. By the way, the issue with the JVM affects many other tools like Topcam and many other comments in Linux. Another part of the answer is the JVM ergonomics. And when no tuning parameters of the JVM, so the JVM is always on hardware agnostic, which means that the JVM will try to ensure itself and to adapt itself to ensure the best execution in the production environment. However, if the JVM, and it does that by collecting some parameters from the underlying host, like the memory, the number of CPU, the CPU model, and so on and so forth. And this is how like the JVM split its memory. But if the JVM fails to collect the good information from the underlying host, like the memory and the number of CPU, so the JVM will fail to deduce the good values, and this nice feature of the JVM, which is JVM ergonomics, will become a nightmare, which is exactly the same thing happened for our friend Ferro. We had a demo about memory, but the same thing applied for CPU. If the JVM fails to get the total number of CPUs, this will impact the internal threading pools of the JVM. It will impact some popular APIs of the JVM, like the fork join pool and the stream API, and it will impact many popular Java software out there. So Java community is aware of the problem, and the work started in order to make the JVM more container aware. But unfortunately, if we are using Java updates 121 and before, as our friend Furrow, the only solution is to pass the tuning parameter and the options to the JVM. Or we can use another cool hack from the Fabric 8 community with the added startup script to the container, which collects the basic information from the underlying host and then pass the correct value to the JVM during startup. Java 9 introduced and added some very basic features and to make it more container aware. Specifically, we added 2 experimental features, an experimental feature for memory configuration, and good luck convincing your manager to use an experimental feature in production. And now the GC thread are taken basically from the CPU set CPUs configuration and taken basically from the container constraint. In Java 10, there were more fine-grained options. More options were added to allow more fine-grained control over the memory usage of the JVM. And another formula was introduced to calculate the total number of CPUs that can be used by the JVM in the container. And we can specify a new option that has been added to specify the total number of processes that can be used by the JVM. In Java 11, basically the work was to fix this one was to fix a misconfiguration or a misusage or a miscalculation of the formula introduced back in Java 10, and it happens, and this issue affects especially the guys using Kubernetes. And in Java 11, we introduced container metrics, and we fixed like some issues that were with the GCND comment and GPS. And of course, we removed the experimental options that were added in Java 9. In Java 12 and 13, the focus went on the Java flight recorder to make it more container aware, and the Java community continued to work to make the Java and the JVM more and more container aware. And finally, it's never a good idea to deploy your application into production without having some monitoring tools in place. So from the Java side, there are many tools available in the JDK itself, many open source tools, and many tools that you need to pay for them. And from the Docker side, there are some basic tools that's offered by Docker and by Kubernetes CLI as well. There are many tools offered by the community, and there are some proprietary tools that you can use to monitor and to keep an eye about how your JVM is behaving and how your container is doing in production. So finally, is it a good idea to run a Java application inside a container? Yes, definitely. There are a lot of features and a lot of benefits to take from the containers technology, but keep in mind that if you are stuck with a previous version of Java, especially Java 8 and before, the JVM is not container aware, and you need to make some tweaks to make it transparent. But Java has and always has a rich ecosystem, which offer a lot of tools and a strong community that offer many tools that make working with Java a lot more enjoyable. And there are many tools that can improve running Java application inside a container and deploy them in production. I think that's it. If you have any question, please feel free. Any questions? Okay, perfect. Thank you.